Welcome back. So this afternoon I show you choreograph. So choreograph is a visual programming environment. So that means you can make very simple program visually. So why we provide that is because we want to have a robot accessible for different people. Even people who don't know about programming or doesn't study software engineering. I have seen some of you are studying software engineering, which is good because mainly you need some software programming skills to do some good application for the robot. So when you create your teams for your project, try to get at least one programmer in your team. One programmers with no programming, because otherwise it will be very difficult for you. But anyway, choreograph can make it increase a little bit the resolution. Choreograph is a visual programming and it's quite easy to use even for people who don't really know how to program. Check. So first I will explain the whole interface of choreograph, then we will go through all the different boxes that we have in the box library. So basically when you launch choreograph, it starts with 3 panels like that. On the left you have what we call the box library, yes? And in the middle you have the diagram view. This is where you will create your program. And on the right you have a 3D view, the robot view. So basically I'm saying it's a visual programming environment because you can just drag and drop some little boxes like that and then link the boxes together to create your program. So you just drag and drop some more boxes, you make the link, and then you can make a flow. So here in the middle is the diagram view. This is your program, your main program. On the left here is the main entry of your program. Here this is the main entry, and here this is the exit of your program. So the robot view is not a simulator. That's why we have a separate simulator. I will show you the simulator today. It's not a simulator. There is no physics inside. It's just a 3D view that gives you some feedback. So when your robot is connected, you have feedback on its current position. And you can also control the robot, so in the other direction, if you put the stiffness. So the stiffness button is here. I used it several times this morning. Okay, if you just click on it, I enable the stiffness and the button turns red. So now if you click on the 3D view, you can click on several links of the robot. And you have a small window popping like that. So you can control the arm like that, for example, just by moving it. But it's not very useful right now, but sometimes it can happen that you want to adjust when you create an animation. Maybe you want to adjust something. It's mainly useful for the hands. If you want to make an animation where you move the open or close the hands, you can use this interface. It's a 3D view, so that means you can move the stiffness. That means you can pan the view, you can rotate the view, because other way around. The next view, we have several views actually. So the next view is the pose library. So all the view can be dock or put like that in different panel, in different tab. And you can reorganize all the view the way you like, except the diagram view, because the diagram view is always in the center of the application. So the next view is the pose library. In this view, you can record different poses. By default, there is 3 poses. And you can record your own pose. So it's not an animation. It's just a pose, one pose of the robot like that. And this is useful if you want to quickly reach this position for the robot. So it can be used for debugging purpose. I used it several times this morning because to use the stand. If I want to quickly put the robot in stand position, I can put the stiffness and click on the stand button, on the stand pose. However, if I do that, don't worry with that for a second. It's not an animation, because if I do that, the robot will just reach the stand pose. You will just move all the joints to go to the stand pose, so it will not stand up. Ouch! Sorry. Okay, so this is just a pose, and when you click on one pose, it's just find the shortest way to reach this pose. So you can have your own pose, like for example, if I want to add this one. Okay, I can just click on the plus button, and I give a name for my pose, and then I have my new pose here. So now if I will record another one to show you. So another pose like give me money. And now if I put the stiffness as the same, if I click on the hello pose, it will go to the hello pose. If I give on the give me money, it will give me money pose. Okay. So you can also reorganize your pose in different folders. Just right click on it, create folder, and make my pose, and then you can remove them inside. You can reorganize. You can also, I didn't do it, but you can also add an image if you really want to have some full image. We provide some image, but you can create your own image. Okay, so basically that's the pose library. It's a very quick, simple library of position. To create the image from the pose? No, I don't think the software provide that. Let me right click on the 3D view.
No, she was asking if you can make the pose without the robot in the simulator.
Ah, yes. Yes, you can. If you just connected, so actually, yes, I should start by that, because for you it's very important. Actually, there is a choreograph can connect to a robot, but it can also connect to the simulator. So to connect choreograph or your PC to the robot, you usually click this button. Okay, connect to. And either you type the name of the IP address of the robot. But if you want to connect to a simulator, then you can also choose connect to a local NAO chip, just like that. So here it's I'm just connecting to a virtual NAO chip. NAO chip is the main program I told you. It's the main program running on the robot. We also provide an RG for Windows and an RG for Mac, an RG for Linux. So if you just connect to local RG, then you have a virtual one. And like I just showed you, you can just click on one limb, there's just one arm, for example, and move the arm, and then of course you can save the same way. You can have the position like up, and then you have this, and you exactly have the same animation like Ibone or hello or arm up. And again, if I connect to my real robot, so I just specify the IP address, or sometimes it appears here, I will be able to also click on the arm up animation. So it's exactly the same. It just depends if you are connected to the local one or a real one. But it's almost the same. Some features, some functionality are not available for the simulator, but most of them are possible. For example, the speech recognition, you cannot do it on the simulator, even if you speak in the microphone of your PC. We don't do it. Why? It's not because we could not do it, we could do it. It's, you know, in the head of NAO is just a processor, so it's the same thing. We could do it, but it's a license problem. Okay, for the speech to text, the speech recognition, we use Nuance, we use external software, and we have license for putting inside the robot, but they don't give license to put in the computer. So it would be too expensive for us to pay that license. So just didn't pay it on the PC. So for example, this feature doesn't work on the simulated robot. What else doesn't work? I think the tactile sensor doesn't work on the simulator, but you have the inertial sensor is working, the FSR is working, the joint you can control them, and the bumper is, I think the bumper are working. When I say it's working, I say it's simulated in a physical environment. We'll show you later. So yes, so here is the pose library, mainly, just to record some pose and use them. Delete it. The next view is the video monitor. So this is just the feedback of the video. This is also working for the simulated. So you have the feedback of the virtual camera. And this, so you have a play pause. And this button are used to record objects. I told you this morning I will show you how to make now, how to teach now to recognize some object. So basically it uses this button. I can show you now if you want. So I take an object, for example, this remote control. I press the teaching button here, and I show the object. And before the end of the put down, and then I can take a picture of that object. So then I can delimitate the object with the mouse, something like that. And then you can give a name. So here, for example, remote. You can also give a side because you can teach the object from different sides. Let's say the front one. And you can do that for several objects. And then actually you just record the object locally on your computer. So then after you need to press this button to send this database to the robot. So you send it, and the other button is just to create a new database, so erase everything, start from scratch, or you can also export it or import it, so save it in different folder on your computer. So later, once you have recorded the object, you can use some boxes, we provide some boxes into the vision folder. And one you should use is vision recognition. So you just trigger the first input box, and here the outputs, the blue outputs, will give you the object which now has recognized. Object recognized by NAO. So I will ask him to say it. So I don't take this say box because this say box just say hello. Like take this say text box, which I copy and passed at the upper level. We'll explain that a bit later. I just want to make a quick demo of the object recognition. And I link the object recognized to the input output say text, so it will hopefully say the object name and the site also. So let's try it.
Remote front, remote front, remote front, remote front, the front, the front.
Actually, he recognizes several times, so he just say it and say it several times. If you don't want to, if you want to avoid that, what you can do also is, once he has recognized an object, you can stop the box. This input is to stop the box. So you stop the box itself, and after saying the object, you can restart the box. Then you start to make spaghetti code.
The front. Remote front.
But it works no matter which direction you give, actually.
Remote front.
And you can put the root upside down and the distance also. It depends on the lighting condition and the object itself. And also the way it's working is it's using the texture of the object. Okay, so you just take a picture of the object, that's how you delimitate it, and you try to find some interesting pixels. So I cannot make him recognize a white paper or a black paper. If the object is too uniform color, you will not recognize it. So that's why on this there was a menu button, so could recognize it.
Remote front.
If it's too small, of course, you see there's not enough pixels here, you will not recognize anything. So it's also good when you learn object to try to use the maximum of the frame, which I didn't do it.
Remote front.
Thank you for the book. And by the way, if you want to, so if you want to use that, I think you will have to test it on the real robot, because in the simulator you cannot bring the real object inside the simulator. But yes, you can make your program and just assume that you will have that, and then sometimes to time test it on the robot. This morning I show you the vision recognition. You could use it. stop the program. The program is still running, so I can press the stop button here to stop it. And in monitor, normally, this is the, you can see remote, front remote, this is the debugging features I was talking. So if you check the vision recognition in monitor, it's useful for debugging. So yeah, basically this is it for the video monitor. Play, pause, and some button to learn some object. The video monitor is also useful when you want to debug your program, especially if you have also face detection, so you want to see if the browser can see. The next view is the project content. So when you save a choreograph file, by default it saves a CRG file. Actually, the CRG file is just a zip file, renamed into CRG, but it's just a zip file that contains different folders and also some external files, and that contains some Python script inside. But we zip it in one file so that you can easily copy the choreograph file to one computer, to another, or to the robot. So here actually, with this project content, you can add some files inside your choreograph project file. Okay, so it will be added to the zip file. For example, you can add some music. So if you want to add some MP3 files, you can add it, and you can also create some folder to organize better your files. So I put some music into a music folder, and then I will test it by using the play sound box. So you can click here the branch for the parameters, and one of the parameters is the file you want to play. So you can type it directly, the one you want. So it's music, blah, blah. You can also click on the browse button, and it actually displays the same window as project content. So that means you can pick up a file, this one, and if you click OK, then you can test the program. So it's actually, it will download all the choreograph files, so also downloading the MP3 files. It's downloading uploading the MP3 files.
Basically, it will do one command at a time.
Yes, when you press play, it actually play. Play doesn't want to play. When you press play, it actually upload the file to a temporary folder on NAO and run it. But you can create many applications like that, many programs, and then upload them several one. But then you upload it in the good place, in the good position, not in the temporary folder. This play button is mainly a debugging play. So you implement your program, you just think you want to test, you press the play button, upload it to the folder.
So later on, you could assign your voice command to an application.
Exactly. Try again. Don't know why it's not working anymore. Usually it works well. So basically, that's the usage of the project content. So be careful also to not leave too many useless files because it takes more time to test because it uploads all the files every time. So you just put some necessary files here. So, and another tips when you program. But for you, for simulated robot, it's not a big deal because when you will press play, it will actually copy everything to a folder on your computer because it's your simulated robot is running on your computer, so it will just copy this behavior. So it's just a hard drive copy from your computer to another place in your computer. So it's usually quite fast. You don't go through the network. So it's not a big deal. Anyway. The next view is the script editor. So this view, you can edit some script, some Python script for some boxes, because there is different type of boxes.
Hello, I'm mobile. Your internet address is 190.
There is different boxes, and some boxes can be a script box. I will show you an example of that. For example, if you enter in this one, then you can see some Python script. So you can actually type some Python script here in this editor. However, it's a quite limited editor, so maybe you prefer to write your code in more elaborate editor. After you can copy paste inside the box. Or you can just make some simple box that loads and run some Python script, which you add into your project. It's also possible. In the project content, you can add any kind of files. MP3 file, I can show you, but it can be script files or even compile library. If you have a C++ module, your own C++ module, you copy it, compile it, and put it into your project content, and you can load it from program. I disconnected the robot. Okay, on the video, we'll use this version. So the next view is the behavior manager, and this will actually answer your question about the play button. So the behavior manager is the view you can use to install some behavior, some program in the robot, and of course you can remove that. So basically, you can click this button to upload a behavior to the robot, like this one. No, this one is to upload the current behavior here, which is empty. He asked me a name for it. But this one you can choose the behavior from your hard drive, and then it will download it. Here, as you can see, I am connected to a local node. Okay, it's written here in the title bar. If you are connected to a local one, or if you are connected to a real one. And when you do that, it's exactly what I explained. Actually, it will upload the behavior to a folder on your hard drive, which simulates the home of node inside the Linux. So that's why I have many applications in this folder, because I have uploaded them. And here I also have many applications, like the one I show you, like the Internet Movie Database, and this one, for example. So in this folder you can also press the play button. There is a little play button here. So if you just press it, it will run the program. And here, this check mark, if you check it, then that means this program will be launched when the robot boots. So actually every time NAO is starting, it will launch all the program check like that. Okay, so here on my robot I didn't launch any program, so that's why after booting he's doing nothing. But if I want to interact with him, I usually launch the main program, which is NAO's Live. This one. I'll just check it, and then every time I restart, every time I boot, NAO's Live is starting.
Can we see NAO's Live in terms of
Yes, you can download it. So even after uploading a behavior to the robot, you can also get it back. So if, for example, I have selected, I can just choose Open. It will download the file in the temporary folder on your own computer and open it. Or I can save it on your computer. So you save it somewhere. So yeah, if you want, I can open it. And so this is for opening, saving this one to upload the files, and this one is to delete the file, delete the behavior if you don't want it anymore. And this button is to stop all the running behavior in the robot. So currently there is no running behavior. So there is that, you can use this knife. You can dig into it, and then you start to be a bit scared, of course, if there is many code inside. Okay. Anyway, you cannot have it. You have no application for this project. So that's mainly the behavior manager view. This is how you can install different behavior. So usually, I think it's a good way to try to split your application in different behavior. I don't know, it depends on you, but if you have a very complex scenario in your project and you have very distinct behavior, it's better to create different files and have just one main behavior that you launch as starter. And then from this one you can trigger one or the other. It's better to organize your code like that. The next view is the resource. Oh no, sorry, it doesn't exist in 1.12. This is a new view. This is the 3D view, okay. So you will have already seen it. The next view is the debug window. So this is just debug some information when you have some error message. When you run the program, if you have some error, it will be logged here. Or you can even log also some information yourself. And you have the undo stack. So this one is just to, if you want to undo several, for example, if I do that, I do it, then I link it. You have all the action here, and of course I can type Ctrl Z to undo it, or Ctrl Y to redo it. But I can also directly click on one step to go to the next step. So that's just the undo stack. And finally, you have the reset view that just resets the default 3 panels. That's it for the view. Any question so far about the interface of Choreograph? No?
The script editor will keep the code you insert, right?
Yes,
No matter what you insert.
you don't need to save, yes. You don't need to save actually. No, not say that. I think it's saved, if you press play, it will save the files. Probably. Because you need to send the files to the robot. Yeah, so after that, what else do we have? Of course, a simple help menu where you can access the API. Again, that's exactly the same kind of API, well, a bit different, but very similar to what I've showed you this morning. And in the connection menu, so I already showed you connect. Sometimes the robot are listed here. Actually, to have the robot here, we use the Bonjour protocol from Apple. So if Bonjour is installed on your computer, normally it's installed in the program, then you see the robot on the same network. And you can just double click on it to select it and choose connect. But sometimes with Bonjour, the connection is a bit slow to establish. So you can also directly type the IP address if you know it. That's a bit faster. This is basically what you have to know about connection. You can of course disconnect from the robot. If I disconnect, I have nothing. So again, in the title bar, you don't have any robot. And I will reconnect to the robot. And after that, you have some for the play stop and debug output. This is the same as this button. It's just some shortcut: connect, play stop. This just shows the debug output. It's exactly the same as this window. It's just a quick shortcut to see the debug information. And this one is to connect to your local RG, so simulated one. Advanced depth, this one you will not need to use it. That's to reflash the robot with the new version of the OS, so it will not happen to you. And the file transfer. So the file transfer, you can actually log into the home of the NAO. So again, the login and password is NAO, just like for the NAO web page. And then you just display the folder which are inside the home of the Linux head. It's really home now here. So you can easily upload some files from your computer to the head. This feature is not working if it's a simulated robot. Okay, it's only useful to transfer file to the real robot.
Can you go to your file? Or it's
Not in this one. It's very. You can go upper level, but then it's blocked to the home. You can do everything in the home, but you can do it in SSH actually.
SSH as a normal user.
So normal user, but I will tell you the password. So now you can be root. Password to be root is root.
Competition, can we request that some special binary be installed?
No, I don't think so. That it depends if you want to use a third party library. Maybe you need to install the binaries for this library, you want to compile it. So maybe you need to SSH it or SCP it, whatever.
So it's possible.
Yes, it is possible. Yes, so yeah, in the NAO, I can just told you can become a super user. The password is root, R-O-O-T, sorry, just root, and then I am root. So, okay. Don't exit to root level. I'm not familiar with the general. You don't want to exit the whole stuff. Just wanted to exit the root level. Yeah, I just want to show you, even if you are just a normal user, you can access the root level. That was your question. So I am at the root level, and yes, if you go back to your own, so you have the same folder as what you just saw into Choreograph file transfer, with exactly the same files. You can delete files, you can create folder, it's the same. Like the test folder here, and then the test folder just appear. So it's really the same. But in Choreograph, it's limited to the home, so you can do strange stuff in the OS. If you SSH it, you can do elsewhere. Sometimes you need administrative right, of course, but then you can do a SU with the root password, and then you can install whatever you want, driver or whatever. Sudo, yeah, I think it works, yes. However, not it's better not. It works. So, yes, I'm thinking about that mainly for you that talk about the Bluetooth dongle. So if you want to put a Bluetooth, no, you talk about cell phone, but I suggest Bluetooth. If you have the driver, you probably need to install the driver in the robot for that. But of course, you cannot do that with a simulated robot. So for you, it's become more complex. I would suggest for your project, try to find something quite easy, because you mainly work with a simulator and you only have one robot for the team. So if you think of having another device and link it, it will be difficult for you to implement the project. Okay. So basically, that's very simple. It's a very simple interface to upload quickly some files if you need to. And that's it for connection. In edit, you just have a redo and some preference for the application, just like the language. Nothing very important actually. Maybe this one is useful for you. If you decide to work with different analogy, so if you want to have a test version, another version of the simulated robot, then here you can specify where is the folder of analogy on your computer. This one is for the simulated analogy. So you can specify which one, you can even specify which version of the robot should be displayed in 3D, in the 3D view when you are playing a local analogy. But you can leave it blank and you will find the default folder. That's for edit. Before box library, I go to file, nothing special, just new project, open project, save and edit. And box library, finally. So it's about here, because the default box library we provide is read-only. Okay, so you cannot add modify box, but you can create your own box library. So to do that, you just go to the box library menu and we choose a new box library, and you create a new tab here, which is currently untitled. But if you try to save, we should rename it like that. We do that again. Name. No, not this one. Confused. Oh, we should have a save other. Yes, so we can type it. Take this one, place it, and then you should do a save as, and then it will rename your box library. Then you can add your own box. If you create your own box, you can add it and group all your boxes into your own library. And if you want to load this box library every time you launch Choreograph, you can do it in the preference. In the preference here, user box library, you can specify your box library that you want to open every time you launch a Choreograph. You can specify several box library. So you close it, you don't need it anymore. I just have mine and the default one. So that's the box library. Any question about the interface? I think I have shown you all the interface of the program. Any questions so far? Yes?
Can I add my own design agent to the box library?
Yes, you can create your own box, and then you can add this box into the box library. So I will show you that in a minute. You can create your own boxes. Is it your question? To create your own box?
In your code language?
Yeah, just after. Do you have any other question about the interface, about the global interface, how to use it? There is some button I forgot to mention. This one here. This is to control the volume directly on the robot. I will try to get my play sound because I think I will do the robot. So you can control the sound directly here. So for you, for simulated robot, is maybe not so useful. Just for the real robot. And you also have the battery level here. And this is the stiffness button, we have seen it. And this is the animation mode button. This one is a very useful button to create animation. I will also show you that, how to create some animation. Well, any more questions about the interface? No? So I will start to tell you how to create your own boxes. How to program the program. And then we will go through box library. And then I will finish with the simulator. So, to create a box is very easy. You just right click the diagram view and you choose add a new box. Then you have this window appearing, and you can first give a name to your box, like for example test. You can give some documentation also. There's some documentation. You can change the icon. You provide some icon that you can use if you like. But what is more important is this: the box type, the input, output, and the parameters. This just defines the whole interface of your box. Let's start with the box type. By default, we have three types: script, timeline, flow diagram. If I choose script, then when I double click on my box, I get a Python script, because it's just a box that contains some Python script. If I choose, so I can edit my box after creation, of course. I can choose edit box. If I choose flow diagram, then when I double click on the box, I enter into another level of flow diagram. So that's the root level, and here is inside the box. So you can make box inside box. They are flow diagram. You can have several levels of box like that.
Execute orders. There are exactly box and the orders, the executing orders, they will go into one box and execute all
Yes.
the box in one box, and the next one will.
Yes. So actually, I answer your question. Actually, I told you, this is the main entry of your program. This is the exit of your program. Okay. If you enter into the box, you have also some input and output in the margin. So this is the input, the main input of your box, and this is the output of your box.
So can I break out from one box and just enter the next one? Break?
Yes, it depends how you link your boxes. Basically, this is just making some links between them. For example, I can drag and drop a save box. I link it from the beginning here, and I link it to the end here. And you will save the text, and then it will trigger the exit of my box, so then it will exit. But I can, just one box is not enough. Yeah, I can do something like that. For example, I can change the language. First I change the language, then I link to save, then I exit. Okay, so if I change the language to French, for example, Chinese, for example, then this is what is doing my box. So you have grouped two boxes into one. So if I link it, I can also link the output if you want. It's just switch the language to Chinese and then say hello. If you double click inside and you want to debug inside, you can also press play here from inside. You can see how the flow is going from inside the box.
So can I design like a switch case for working? If I want to design a switch case, can I use different box and
Yes.
use the flowchart to let users?
Yes. Yes, you can do a switch case with boxes, and actually we provide a switch case. But I will show you that with go through the box library, so we will show different box we will try. But definitely, yes, you can do that. Choreograph is a visual programming environment, which means you can program just like any program, but it's only visually represented. This is not the only visual programming environment in the world. You have other visual programming environment like that. For example, you have LabVIEW. I don't know if you know this software. LabVIEW is also a visual programming environment with boxes, you drag and drop. It's the same logic. So one box is a brick of behavior. And the brick can be a big brick or can be a very small one. And the brick can contain other brick inside. We just call them boxes. Oh, so it's back to the English.
Hello.
So that's flow diagram type of box. Now if I choose timeline, when I double click inside, I got the flow diagram, but I also got the timeline. So the timeline is used to create an animation. So basically, the time is going from here to there. You have numbers over there. These are frame numbers. And if you want to, I should not show you the 140. I'll show you the 112. So otherwise, I may confuse you. And so it's a frame numbers. So that you create the box. And this box. So timeline. So this is the frame number, and if you click the edit button, you can see the FPS, which is the number of frames per second. Frame per second. So here it's 10, which means frame number 10 equal 1 second. So here is 1 second. Frame number 20 is 2 seconds, 3 seconds, 4 seconds, etc. Okay, but basically this is frame numbers. We can also have, in the timeline calculation box, you can also have diagram. Yeah? To have that, you need to press the plus button on the behavior layer. Yeah. Okay, so you can actually have several behavior layers. If you click several times on plus button, and each one can have different behavior, different boxes inside. For example, you can have a say here, and you can have another one, and you can have I'm insisting on this, but if you want, so that means what? That means when the time is moving, it will trigger the behavior. And I can move the keyframes. So for example, I can move this keyframe here. This one, I just drag and drop the keyframe. So for example, like that. And this is where you put the animation in the timeline. So it's playing, when this box is playing, it's playing the animation. And when the time reaches the keyframe, then it starts to play the behavior, to launch the behavior inside the keyframe. You can also add more keyframe, insert keyframe on the same track, on the same behavior layer. You just right click on it and choose insert keyframe. So that means when the time will reach this position, it will start keyframe 38. Then the time will go until here, and when the time reaches this one, it will stop frame 38 and start frame 61. And the animation now, how to create the animation. This is usually quite easy. I'm trying to copy this time. And for that, well, it's quite easy with a real robot, but with simulated robot, I'm not sure. So you can use the animation light button here. I will explain you this. So I will briefly show you. You just click this button. The robot makes sound. And you can enable or disable the stiffness of the robot by touching some part of it. So for the head, you just touch the skull, and you can remove the stiffness. So maybe you want the head like that, the stiffness also. It's not very important for the head. And for the hand, for the arm, you touch the hand. So you can move the hand like that. If I release it, it falls on. But if you want to keep this position, you can just touch the hand like that. The stiffness is set. So basically you can check if the stiffness is set or not by checking the corner of the eyes. So maybe you don't, or you over there you don't see it. If it's blue, that means there is stiffness. So right eye is blue is stiffness on the right arm. If it's green, there is no stiffness. So you can hold the hand, it becomes green, move it, you release it, blue. Sometimes you lose the stiffness because you can also voice command it. So, for example, if I say left arm, left, so yes, you change the stiffness. Left arm, so you see, you can switch up. So why I'm demonstrating you at the same time I'm speaking and you just hear me saying arm or whatever, so you change the stiffness sometimes. It's not very convenient to make the demonstration. Honestly, the voice command is not very important, but what is more convenient is touching this arm. And for the arm, for the legs, you can press the button here. And the leg here indicates there is stiffness on that. It's green, no stiffness. It's blue stiffness. So basically you can move like that, put it like that, and put it back in the stiffness, and that's perfect. But of course, more like before. But basically, do that. So after that, you right-click on the timeline and choose Store Keyframe. That's why I didn't want to say anything. You choose Store Keyframe, and it will just record the position. So you can do it for many position, and then of course when you play the animation, it will blend between all the different positions. But okay, I will do a very simple animation to make you understand. I forgot to mention that I may have break my robot. We'll see. I forgot to tell you that when you click on the timeline, it actually goes to that position. So that's why it's important to do that either on the ground or you are next to it. You can catch it. Here, there's no next to it. You can catch it. Okay, let's try it. So, as you can see also there is a shortcut which is F8, okay, if you want to start the whole body, F8 or F9, F10, F11. So basically you just move your robot just like I show you, and then you just press F8, press F8, you can record several keyframes like that. So for example, we do that, and we record another frame, F8, and then we will record another one. Okay, and then when you are finished, you can exit the animation mode. Put back the wall stiffness, and you can press the play button here, which replay your animation by blinking between all the frame position. And that's just display button is just for animation. But of course, now if you want to play the whole box, including the behavior, we should of course play the whole program. I will delete this keyframe, I don't need it. So we'll just link it. And I will try again by behavior. We'll see. So, and then it's finished. We can double check inside what happened. You will see the red bar moving with the time. So I will launch the behavior. So, sorry, you don't have the animation. But basically, the first keyframe here is playing the sound, okay, the kalimba sound here. So we start the sound from the beginning, and here at that time only, I just say hello. So I just say hello a little bit later, and I can adjust that so I can synchronize my say hello with the keyframe of my animation. This is a way to make a dance or to make some move and say something or act or do something. Synchronize with an animation. So that's the timeline type of box. To summarize, we have three types: script, timeline, and timeline. Script, sorry, flow diagram and timeline. And even the timeline and even the flow diagram box can have some script. You can edit the script. Just by right-clicking on it, so you can choose edit box script, and you also can edit the script. So basically, you have a different level of complexity The easiest one is the script box, only script. Then you have the flow diagram, which contains flow diagram and the script. And then you have the timeline, which has an animation timeline, flow diagram, and the script.
Statement removed.
So that's for the different type of the box. Any question before we switch to the input, output, and parameter? Okay. Do you want to make a break, or at what time do you want to make a break? I don't know. What time? It's 5. Yes. So maybe 3:30. Okay. Break. Okay. So now let's see the input and output. So you can add some inputs and outputs. You just press the plus button. For example, here I just add an input. You have this window appearing, and of course you can type the name for your input, for example, message. And you have different types for the input. So you have 4 different types. By default is the bank type. So the bank type, you can see it as a kind of event. It's just you trigger the input, you just send an event to this input to trigger it. Or you can have a number, a string, or it can be dynamic. And dynamic means it can be any of the 3 others. So here, for example, I create a string input, and I will delete the default one also. I'll delete the other one. Okay, so I have created this one. I will delete the output also. Okay, I have message. I will create a number input, like I don't know, 8. I will create bank type. And I will create a dynamic one. So here is my form input, and you can notice that we have different color depending on the type. So the string are blue, the number are yellow. Oops, sorry, I have to switch them. The number are yellow, the bank type are black, and the dynamic type are gray. I can do the same thing for the output. String. Number. Bank. And anything. Oops. Okay, so I have the same color for the output. Now let's look at how you can link them together. For that I just copy paste my box. Copy paste. So of course you can link a string output to a string input, but you cannot link a string to a number, because a string can be I don't know, hello world or whatever. You cannot convert to a number. You can link a string to a bank type. In that case, the value is just indoor. Just don't care about the value. We just want to trigger this input. You can also link a string to anything, to a dynamic type, because the dynamic input can be a string. For the numbers, of course, you can link a number to a number. You can link a number to a string. In that case, the number is converted to the string representing the numbers. You can link a number to a bank, so that's the same as for string. We just ignore the value. Okay, which is the fact that the input is trigger is important. And you can link a number to dynamic input, because the dynamic input can be a link. For the bank type, of course, you can link a bank type to another bank type, but you cannot link a bank type to a string or a number, because bank type there is no value, no data. And the string input is requesting a string. The number input is expecting a number, so you cannot directly link like that. But you can link your bank type to a dynamic type, because the bank type can be a dynamic. The dynamic type can be a bank type. And finally, you can link your dynamic output to anything, because a dynamic output can be anything. So this is the link compatibilities between input and output. I don't need that anymore. Maybe you have noticed there is another kind of type actually for the input, which we call nature. So that's the main type, and you have another thing which is nature. For the nature, we have 4 different kinds of nature: on event, on start and stop, and idle input. On event is the default one. Let's look at the on start. I will create message on start. For the 8, I will choose the on stop. So the on stop. And I can create another memory input. So if you choose add memory input, actually this input, I told you this morning, you can register a callback on memory value. So actually this input will be triggered when the value changes. So you can give which key you want to link. You can also browse it. So for example, if you want the foot contact change, for example, you can link it like that. So I told you the color indicates the type, and now we have little icons inside the little box. The icon indicates the nature. Okay, so on event nature, there is nothing inside the box. These two are on events. On start nature of input, there's a little play icon, and on stop, there's a little cross icon. So what does it do? Well, it's quite simple. If you trigger an on start input, it will start the box. It will load and run the box. But if you trigger an on event input, nature of input, the box will not be started. Okay? So only if you have an on start nature that this box will start to run. On stop, the red cross, if you trigger this, it will stop the box and unload everything inside. And like I said, on event doesn't start, doesn't stop the box. Okay, so on event input is just here to feed the box with new data. And if you want to send new data inside your box, but you don't want to disturb the running of your box, you can just use the on event nature of input. If you look inside your box, the timeline box, you can notice that you don't have the on-stop input. And you have this one, and this one, these three, but you don't have the yellow one. Why? It's because you will stop the box. So it's useless to start some new behavior for something that will just stop the box. Okay, so here on this margin you only have the on start and on event inputs. Plus this little gray one, which is our memory input. So this one is a bit shifted with a small icon, and because it's an event that will come directly from memory. Let's look at the nature of the output. For the nature of output, we only have two, on stop and control. By default is control. And if I choose on stop, then I have another icon appearing here. And if this output is triggered, then it will stop the box. So the on-stop nature of input is a way to stop the box from outside the box, like that. Okay, if I trigger this, I cannot because it's a blank. Okay. If I trigger this, if I trigger this input, I will stop the box from outside the box. And if I trigger this output, I will stop the box, but from inside the box. All the software engineers are following me. The other one. Basically, that's the difference between type and nature. Yes.
Won't the box stop anyway when you finish this?
No, just stop. It stop where it stop everything and unload everything. So you can be in the middle of an animation and the animation will stop.
Okay. But let's say you want the box to finish, you don't have to technically stop, right? Because it will finish anyways. It will continue the flow. Will continue.
No, if there is nothing that it depends on the kind of box. If it's a timeline type of box, this box will finish when the animation is finished. For a flow diagram type of box or a script box, no, you have to trigger the output. You have to trigger on stop output.
It's not just be waiting.
It's just waiting, yes. Just kind of idle. That's why, you know, if I can show you, if I just do that, lost my connection. I should remove the camera from the.
Hello.
If I just do that, the program is still running. That's why you have the red cross. Because I didn't trigger the output here. But
So you can't start another behavior till you finish.
no, you can. If you play again, it will stop the current one. But it's a choreograph that will kill the current behavior. So we'll do this one. But now, if you link it like that, I stop it manually. But if you press play,
Hello.
and say hello, and then the program trigger the exit, so it will start. And I just demonstrated at the top level, but this is the same logic at other levels. So sometimes you want to trigger an output, sometimes you don't. And you want just to have something ready.
By triggering this in a lower level, you actually will get an output. If it's a string start, you get a string that you can use some.
Yes, I'm not. Yes, exactly. Yes, at another level. So you just send a string out and stop your box. But maybe your box is computing a result or whatever, and the result is the string. It's the equivalent to return a string in C++. So, yeah, that's for the, oh, I think I have deleted my box. Let's move it back. Okay, get it back. That's for the input and output. Now let's look at the parameters. You can also add some parameters to your box. Just press the plus button. And you have different tags here. Boolean, integer, float, string, or a file. We can start with Boolean. Check. You can also specify the default value for these parameters if you want to check or not check. Check. Or create another one like the text, and you want a string. Oops, string. So the default value can be and you can also make multiple choice string. And if you choose a number, for example, integer, you can specify a number with a minimum and maximum value. And then when you do that, you have a little range appearing in the corner here. So if you click on it, you have your parameters, which of course you can change to something else, and that, and you can change the number from minimum to maximum value. And if you click to reset default, then you get back your default value. Okay, so this, after these parameters can be used inside your box.
They're just like input.
Yes, they are just like input, and you can even do like a real input, because you can actually link one output to a parameters just by linking on the branch, and you release on the branch, and you can choose the compatible parameters, like for example the text, and then you have a little valet appearing here. So you will tell me, but what is the difference between input and parameters? And I will just answer, this is a matter of design, how you design your box. And usually you create the parameters if you have a default value. If your box can work with a default value, and you create an input if you really want a necessary input for your box to really work. So it's just a matter of design. Plus, of course, you cannot launch a box just by linking on parameters. If you want to run a box, you really need on started nature of input, of course.
This text editing box, what is that?
We will go through the box library just after, but I can answer immediately. It's not a big deal. This, you can see it as a casting box. It actually casts a bank type to a string type, because you enter with a bank type which has no value. You give a value, and then you have this string hello, which will be sent to the output. So it's a way to connect the black to a green to a blue one. And you also have number edit box, which is doing the same thing. You can name the black one and you get the number which you choose here. So one more word also about the parameters. If you choose attach file, you can also specify a different file name, for example. When you click on the parameters, then you have this little icon, and it will open the project. Okay, so if you want to have parameters that load a file from our set and from your behaviors, it's also possible. So, yeah, I think we have seen everything. Advance is not important. Yeah. So, do you have any question about inputs, output, parameters, the box? No? So I will show you something more about the script. I created a new box, just a default box. I will just create a new input with my name. Yeah. Another one I will create with Eric name. This time I will choose a number. So if you just create a box like that, and it's a script box, so when I double click on it, you can see that there is some function created, some Python function created. And basically we create one function which name is onInput underscore, and the name of the input, Albon or Eric. And Albon is a bank type, so no parameters, and Eric is number type of input, so it has p parameters. This is Python script. So for those who doesn't know Python, and I know very few people know Python here, I may say something about Python. Python is a script language, so it's an interpreted language. And there is three important things to know. The first thing to know is it's a tabulated language, which means there is no open bracket or closed bracket for block code. Instead, we use the indentation. That's why there is little lines here. You don't see that here. Okay, so one indentation defines a new block. The second important thing is to know is the self parameters. So the self parameters here is the equivalent to this in C++. Okay, the reference on the instance of the object. Here, for example, we have a class, so with the class keyword, just like in C++, it's the same keyword to define the class. That's the name of the class, and that's the parent class, inherited from this one. So this one is inherited from this one. So the self is equivalent to this. And the third thing to know is that the scripting language doesn't have a strong typing variable. So the variable are not strongly typed, and the variable can change type. So that's why there is no type for the parameters here. It can be a string, a number, you can change it, you can narrate, whatever. So, but basically, for every input, you have one function on input and the name of the input plus a parameter or not, depending if there is if it's bank type or string type. And for the output, this is the same. You also have one method for each output. And the method name is exactly the same as the parameter. So, here, for example, I have on stop. Okay, that's the name of my output. It's called on stop. So that means if you want to call this output from script, you just type self on stop. For example, here. Yes, easier to see. For example, if here I want to call the output, I will write something like self on stop. Okay, and if your output is a string or a number, you can also give the value, like here, for example, if it's a pointer or if it's a string, I don't know. You could write something like that. If you change this output to a string. So it's quite easy. But just one thing is, once you started to edit the script here, even if you edit the box by adding new input or output, it will not add the definition of the new script. Because you started to modify the script, so after that you won't touch your script anymore. So if you want to add an input after editing the script, you can also manually add the definition of the function. Okay, any question? I think I will do the pause right now, because I think I have finished to explain you the programming part, the box programming, and then we can look at the box library, all the blocks we have, and then I will finish the day by some NAO scene test. Okay, so 15 minutes, something like that.